Hello everyone, welcome to this Python tutorial. In this video, we're going to look at tensors and their operations in Pytorch, and also going to look at automatic differentiation in Pytorch, how to train a neural network. So we'll start with how to load your dataset into Pytorch. Pytorch is one of the most popular deep learning frameworks that we have. The basic data structure in Pytorch is a tensor, so everything that you work on in Pytorch has to be on tensors. So you might be wondering what these tensors are. So these tensors can be anything. A tensor can be a single number such as this one. In this case, we refer to it as a scalar value. Or it can be a vector such as this one. The ones on the top, these first three have special names. So this can be a tensor, and this is just a single number. Or we can have a tensor with one dimension. In this case, this has a special name. It's called a vector. Or it can have two dimensions. So this is two-dimensional, and we call this a matrix. And then you can have three-dimensional object. For example, in images, you have RGB, and this creates a three-dimensional object. So once you get to 3 dimensions, we just call them tensors. But usually for the first three, we have special names. You can call it a scalar to be more specific, or we can call it a vector. That means it has one dimension. It's a one-dimensional tensor. Or we can call it a matrix, which is a two-dimensional tensor. So the general name for all these is they're just tensors. But if you want to be more specific, to provide more details about what you mean, you can say you're working on a vector and someone will know that, okay, this is one dimension. Or you can say you're working on a matrix and someone will know that it has 2 dimensions. Or you can say it's just a scalar and someone will know that it has no dimensions. So I'll open up Pytorch here. So the first thing that we want to do is we want to install Pytorch. Here I'm using Google Colab. In Google Colab, it's already installed, so you don't need to do any setup. Just import. Let's see the version that's installed. So we can say touch dot. So you see that this is version 1.9. And to create a tensor, which is just a scalar value, just a touch. So here you see that this is a tensor, which is a basic data type that we use in Pytorch. A tensor has several attributes. One of them is the data type. And the other attribute you can specify is the device on which this tensor should be. And you can also specify whether the tensor requires gradient or not. So in this case, we're just looking at simple tensors. We're not going to require gradient. And for the device, you can specify whether the device is CPU or GPU. And for the data type, you can specify any data type that you need that tensor to be in. So this one, because we haven't specified anything, this is an integer. So we can say if we want this to be float, we can say touch.float. So as you saw, this is default float 32. So we can just leave it here. So you see that now when it shows the point showing that this is a float tensor. To create a vector, you can simply say touch.tensor. And we can pass in a list of values such as this. So now this creates a tensor, which is a vector. So let me give this a variable name. So let me call it x. One thing that you can check is the size of this, and this is a function. You see that this has only 4 columns. Now let's look at how we can create a 2D tensor. So for a 2D tensor, you have to have a list inside the list, for example, 1, 2, 3. And then I have the second part, which is the second D. So you see here, there are 2 brackets here. So this is a 2D tensor. So when I do enter, you see that now we have a 2D tensor here. So for example, if I assign this to a variable and then I check the size, you see that now we have 2 rows and 3 columns. So which is exactly the shape of that. So now let's see how we can create a tensor with randomly initialized values. So this might be useful, for example, when you're trying to initialize your network. So you can just say touch.rand and you specify the size of the tensor. And you see now it has created the 2-dimensional tensor. This is a 2-dimensional tensor with 3 rows and 3 columns. So for example, if we wanted to create a 3-dimensional tensor, we just provide the 3rd dimension. And you see that now we have 3 dimensions. Sometimes you might want to create a tensor with ones, and for that you just say touch.ones. And same, you just specify the dimension, and this will create a tensor with just ones. And if you're interested in a tensor with zeros, you just say touch.zeros. and the dimension, and this will create a tensor with zeros. And what we've been doing here, we've just seen like different ways of creating a tensor. So we've looked at creating a tensor with a randomly initialized tensor, or using a tensor with ones or a tensor with zeros. Usually you don't want to just to create tensors, you want to do some operations on these tensors. So let's start with 2 tensors. I'll say 3 by 3 tensor, and let me create another tensor which is also randomly initialized. Some operations we can do on these tensors, we can add them, and this would just do simple addition. For example, this is just simple addition. Each number is added. So if you see x and you see y, this addition is element-wise addition. So this, the first value will be added to this corresponding value, and you have this value added to that value. So that's how you do like simple addition, element-wise addition. And if you want to multiply these 2 tensors, you can just use a times, and this will multiply them element-wise. This is basically Handaband product. It just does element-wise multiplication, 0.55 by that. It's not matrix multiplication. If you want to do matrix multiplication, you can use matrix multiplication like that, and this would do a matrix multiplication of x and y. Now let's move to auto differentiation. For example, given this function, you might want to differentiate this function and to find what this function will be at a particular value of x. So this, if you have to do it manually, to take you time, but so Pytorch offers a way that you can automatically differentiate any function by just following the operations that you do on your tensors. And this is one of the biggest advantages of using Pytorch for deep learning, because in deep learning we deal with very complex functions, and having auto differentiation just simplifies everything. So for example, here let me create a scalar that requires gradient. So this is x. So let me show you x. So you see that this x now, it shows that it requires gradient. So if it doesn't require gradient, that is ignored. You can check that whether something requires gradient using the requires gradient property, and you see that this requires gradient is true. So for the previous tensor that we defined, if we check whether it requires gradient, you see that this doesn't require gradient. So let's look at this simple function here. I've just defined y is equals to x to the power 3. And from calculus, you might remember that the differential of this function is simply 3x squared. And for x is equals to 2, which we've defined here, x is equals to 2. We expect the differential to be equal to 12. Or the gradient of this function, we expect it to be equal to 12. So let's see how Pytorch will work out. So we'll say y is equals to x to the power 3. And now let's see what y is. So you see that y is now equal to 8. So we can calculate this gradient by just using calling backward on this function. So now if we check this, what the value of y is, we'll see that the value of y is 8. So to calculate the gradient of x here, just say backward on y. And this will calculate the gradient. So now to check the gradient in x, I just simply say x.grad. This will show us the gradient that has been accumulated in x. So now if I run this, you see that this is 12, which matches what we calculated when we use the analytical function here. So now let's look at how we can finally train a neural network in Pytorch. So the first thing that we want to do is to load the dataset. Then we define a model, then define an objective function, and then define the optimizer. And finally, we want to define the training loop. So for the dataset, we'll load it from Touch Vision, and we also need some transforms from Touch Vision. Most of these details might not be familiar with most people. I'm going to make a next video that will deep dive into this concept. Here I'll just give a quick overview so you can have a sense of how easy it is to train a neural net in Pytorch. In the next video, we're going to look at the actual details. To train our network, I've written this boilerplate code just to make it faster for this explanation. So here, first we create a transform, and this transform is composed of two things. The first thing is to convert all the pixels to a tensor. We normalize all the images, and we define a batch size here of 8. From Torch Vision, we have a dataset, and here we're loading the CIFAR10 dataset. So we want to first get the trained dataset. We specify that with true. And we want to download this if it doesn't exist, and for the transform we specify that transform. And here we create the data loader for the training set, and we test set, and we create a data loader for the test set. And for the categories in CIFAR10 we have planes, cars, birds, cat, a deer, a dog, frog, horse, sheep, and a truck. I'll just run this, and this is going to download the CIFAR10 dataset. So for the files we can easily check here in Google Colab. So I did an in-depth video on how to use Google Colabs. You can check that if you want to see other functions. So you can click here, and this is the dataset that we're looking at. I've already defined the neural network, so just to save some time for this video, so I can make this video short. So for that we use torch.nn. So here we just load it as .nn. And for the neural network, we need to use the nn.module. We'll go in more details in the next video. And for this one, I've used convolution 2D with max pooling. And finally, we have 10 classes here in the output. So this is FC3, 10 categories in the output. So I'll just run this to get our network. And here we can get the device. We can either put this on GPU or CPU. So if we check our line time here, you see that now I'm running it on CPU. So this will just show CPU. But in future, I want to use the GPU, not CPU. So if you click this, there's GPU and TPU. And then next, we want to define the criterion, which is the objective function. So for this one, we're using close entropy loss, so which is also defined in the neural network module. So I'll just run that. And then finally, we define an optimizer. So for optimizer, I'll find them in torch.optim. And here we're using the SGD optimizer. And the first thing that we specify are the network parameters, so which is just the model and dot parameters. And for the learning net, we're using 0.01 and some momentum for this. So this is SGD with momentum. We'll go in more details in the next video. So let me just show you how easy it is to do it in Pytorch. Finally, let's look at how we train the model. So here I'm using TQDM for the progress bar. So for the first one, the title of this progress bar is epochs, and the second one has no title. So the first thing that we do is just to get the data from the data loader. From this data, we have inputs and labels. And then the first thing that we have to do is to zero the gradients for all the parameters. And then here we do the forward pass through the network. And then using the outputs, we can create the loss and then do a backward. This automatically calculates all the gradients, and the optimizer will do one step here. So now the model is training, and it has to do 6,250 steps. So this training for our simple model is now finished. So we just did that 2 epochs. But this is for demonstration purposes only, but we might need to do more epochs to actually fit the training data. So you see that for this simple training, which didn't even fit the data, we get around 58%. If we train this model longer, I would get even a much better performance. So for demonstration purposes, I think this does the job. As you can see from this quick introduction, it's very easy to test the neural network in Pytorch. The next video will be an in-depth study of how to create a convolution neural network for image classification in Pytorch. So look at exactly what's going on here, what's the convolution 2D, what's max pooling 2D, and we'll cover what the LELU is and what it's doing here, and how to define the forward function and everything. We're going to cover it in more detail. If you are interested in that, look out for the next video. Make sure you subscribe so that you can be notified when I upload the next video. Thank you for joining me. Make sure to like and subscribe to this channel.